With that, welcome to the virtual user group for DB2. We're excited to have you. My name is Amanda Henley. I'm with Managing Editor of Planet Mainframe, and I also have the privilege to host this virtual user group series. We have virtual user groups for IMS, KICS, and the one you're in, DB2. So if you're interested in other user groups with us, you can go to virtualusergroups.com, find out all the information, and sign up for future events. Our next virtual user group for DB2 is in 2 months, as you probably know, but we do have a session next month as well. So a couple of quick things before we dive into our presentation. I want to thank our partner, IntelliMagic, for sponsoring this series. They have been such a great supporter of the user groups for many years. So I encourage you to check them out. As you know, they're an IBM company now. And then I wanted to let you know also that we have a partnership opportunity coming up. So if you are interested in becoming a sponsor of our user group, you can reach out to me. I am ahendley@planetmainframe.com, where you can find me on LinkedIn or, you could check me out through Planet Mainframe. Pretty easy to find. Drop us a line and let me know if that's something you'd be interested in. I wanted to let you know at Planet Mainframe coming soon. Next month is Observability and Resiliency Month. So we are looking for contributions still for our editorial calendar next month. If you've written about mainframe observability or resiliency, would love to read what you've got so that we can consider it for publishing. After today's session, we'll have a very brief exit survey. It's 2 questions. I promise they're not hard questions. So if you would take a moment to let us know how we did today and to let us know if there are any topics you'd like us to cover next. And now we're just about ready to get started. 1 second, I'm looking for one thing. So I wanted to let you know, so Emil Kotrc is joining us today as our speaker, and he is actually going to be speaking next month at IDUG North America in Charlotte. So I just threw up the topics and dates for you. Great conference. I encourage you to go check it out. Emil and I were talking. I might see you there. I've got some travel conflicts popping up, but please do go check it out, and you can see him live and in person, and it'd be a fun opportunity. And I think he's going to tell you a little bit more about some work he's done with IDUG2 in his presentation. Now it's time for our session. Can DB2 for ZOS be hacked? I'm going to stop my share. If I can find the button, there's the button. Emil, I'm going to let you take over and share your screen while I introduce you. So Emil is an experienced principal software architect. He's got a history of working in the computer software industry, and he is skilled in IBM DB2, agile methodologies, databases, and on the mainframe. He's got a PhD focused on mathematical engineering from Czech Technical University in Prague, and he's an active member of IDUG and on the IDUG Content Committee. And he's been an IBM Champion since 2015. So are you able to share your screen, Emil?
Yes, hello. Thank you. So I'm just clicking on the button. Hopefully.
Great, I can see it.
Yeah.
I did want to mention, Emil and I talked about this before y'all joined. If you have any questions during the presentation, you can drop them in chat, or you can, raise your hand and come off mute and interrupt us. We will also look at Q&A at the end. So if you need a point of clarification, just drop it in chat or let us know during the session. Otherwise, we'll do Q&A at the end. All right, Emil, I'm going to turn it over to you.
Yeah. Thank you, Amanda. So hello, everybody. Thank you for joining and thank you for having me here. My name is Emil Kotrc. I work as a software architect in Broadcom. I'm with Broadcom. I'm based in Prague, Czech Republic. So my time currently is 6:30 or so. So it's getting late. So hopefully it will be still okay and I am still focused. So as Amanda said, I will be at IDAC in Charlotte. I'm already booked, so I'm looking forward to be there. But my topic will be a bit different than this. So this session is based on my prior session I had at IDAC in Prague. Yeah, it was in Prague last year, and also with GSC UK. So some of you may have seen it already, and if you did, I only have few small updates, but hopefully it will still be useful for you. So let's start. So the title of the session is "Can Db2 for ZOS be hacked?" And the answer is pretty clear. Yes, it can if it's not secured, right? And this could conclude the session. But I have a few more slides to go. So but just bear that in mind that Db2 can be hacked really, and I will show you some examples how that can happen if you don't have a secure environment. So first of all, a warning. So I'm not a hacker. I don't hack computers. I don't hack mainframes. So I did this with all good intents, just to help you securing your environments. So please use this information wisely to educate yourself, educate your teams, and make your Db2 more secure. So there is some sensitive content included, but I mean, it's all documented. So I don't have any secrets here. All is either public or on GitHub. So I will show you some tools that can help you. And all information I have here is from the Db2 documentation that is available. So I have no reverse engineering topics here, no zero-day vulnerabilities, no anything like that. Really, everything is public and available. Oh, of course, everyone tries ChatGPT. I did last year, and the answer was that I'm sorry, I cannot provide instructions, which is understandable. So, but maybe this has changed since the time I tried. I didn't try it since then, but maybe you can try, and you might get some information from these tools as well. So this is my agenda. So I will start with a brief introduction of myself so that you know who you are talking to, but you already have heard the introduction. So maybe I will just be very brief here. Then I will speak about what I mean by definition of a hack in the context of Db2. So what I mean by hacking Db2. So I will discuss that for a minute. And then I will show you 3 simple examples. What can happen if your environment is really wide open, and what can happen easily. And I will be speaking about 2 local hacks and 1 remote. The next section will be about Db2 security in a nutshell, and I want to point out some important things and things that people sometimes confuse. So that will be like the half of my session, and the rest of the session will be focused on more general topics about I will talk about the hacking community, the mainframe hacking community, and the tools that are available. And I have a lot of links to GitHub and some sources you can use. And then I will talk about the common attack vectors, which are really common, that can attack the mainframe. And my first section basically is just put these into context of Db2. And at the end, I will talk about the prevention. So what you should do next, or what can be the next actions, and so on. So let's start briefly about myself. Normally I don't do that, but in this session I do that because I want to show you that I'm a good guy. So I'm relatively new into mainframe. I joined the mainframe world back with Db2 8 and Z9. So my first ZOS was 1.7. So in the mainframe age, I call myself a teenager, which is good. So that's why I can do these crazy things like this session. As I said, I work for Broadcom in Db2 tools, research and development. My current role is one of the architects of Db2 tools. I'm based in Prague, Czech Republic. And I'm also a member of the IDAC content committee, which I will mention in a minute, because that's the context why this presentation is happening at the moment. Yeah, that's what I said. I'm not a hacker. I wanted to show that I'm a good guy. So I try to find some hacker-like pictures of myself. This is what I found. So I just typed computer into the application, and this is what it showed me. So, okay. So I mentioned I'm also a member of the IDAC content committee. IDAC is an international Db2 user group. I guess many of you are aware of of IDAC. And we have some monthly content, monthly topics. And back March this year, I was leading the content articles, and I was thinking about a brief security series. And I was traveling, I was at Share in Orlando, and of course, I had the jet lag. So I woke up at 2 a.m. in the morning. So, and now what? So I wrote a brief article about, can Db2 be hacked? But I wanted a second part, and I asked Gaia from IBM if she could write a second part, how to make Db2 more secure and compliant. So, and that's what I call this security mini-series. So if nothing else, and you want to learn more how to make your Db2 secure, make sure you read article from Gaia. Article from me, I mean, that's what I will just talk about in this session. So it's just like a teaser for the second article. So here are the links to these two articles. So I would recommend reading the second one. It's an overview of all the techniques you can use for Db2 to make it really secure and compliant. And actually, this is why I'm here, because I think Amanda noticed that article at IDAC, and she asked me if I'm willing to speak about it. So here I am talking about my article and my prior session. Okay, so that was the intro, and now let's go to the real business. So definition of what I hack. So first of all, can a mainframe be hacked? Back then, when I started with mainframes in those years ago, I was told that mainframe is the most secure platform and it can be hacked, and we were like trained that all is safe. But later I learned that it really can be hacked, and there were even some cases where mainframe was hacked. In 2013-14, I was attending a conference in the Nordic region, in the European Nordic region, GSC Nordic, and there was a session about one of the hack. And maybe you have heard about this Anakata case, and that's a pretty famous one because there are a lot of information that are on GitHub and some other spaces where you can learn more. And that was an example of how a hacker who didn't know anything about mainframe was able to learn and hack into and do some bad things there. So, I mean, that's where I like, this was this eye-opening, and that's where I learned, oh, yeah, maybe it's not that secure if you don't have it secured. So, and that's the point here. So if you have mainframe, most likely it's very important for your shop, for your business. So make sure you have it secured. But on the other hand, there are also typical myths and issues, because what I hear sometimes is, oh, this is the most secure platform, no one can hack into, and even if they do, they don't understand the basic terms, like what the data set is, whatever. But I mean, just look at those examples I have on top of the page, that this really happened even by hackers who didn't have any prior knowledge about the mainframes. So definitely be open-minded and listen to your folks and to your employees. And if they think, oh, maybe this is not secure, should we change that? Really be open-minded and think about how to change, or how to change your configuration to make it more secure. There are already some known vulnerabilities. If you are watching the security portals, you can watch the CVEs, and especially what's important is the scoring system CVSS, which can tell you if the vulnerabilities is local or remote, and some other metrics. So usually those mainframe PTFs are in security are not very descriptive, so there are not many details, but still CVSS might be there, and that can help you to assess whether this is something that can affect you or not. So I have two examples here. IBM Security Portal. Maybe you already watch this space. You get some notifications. Broadcom has security advisories, and I'm pretty sure other vendors have them as well. I just don't know them, but I'm pretty sure they are there. So watch your vendors, watch IBM, and make sure that you apply the security fixes as soon as possible, because this is critical. On the right hand, the picture is the CVSS calculator. I just wanted to give you an idea what the CVSS scores gives you. So you can see like what's the attack vector, if it's network or local, if privileges are required, and so on. So this is really the thing that can help you to understand what's the attack vector of the problem. So now what I mean by definition of a hack, and now I start talking about DB2 more. So what do I mean by hacking DB2? So I have three points here. So first of all, it's like if I'm able to access the data I normally wouldn't be allowed to access, and it can be through DB2 via SQL or even outside of DB2, if I can just dump or read the physical table spaces. That's also what I mean by hacking DB2. The other example is, what if I am able to get higher privileges than I have? So I start as a regular user, I have select privilege to some tables, and suddenly I'm able to escalate my privileges to sysadmin, for example. So that's a hack as well. Or what if I can break the DB2 subsystem? What if I can bring it down? What if I can break it or stop it? I mean, that's what I consider as hack as well. So these three are like what I consider as hacking DB2. And now I will speak about some specific examples. I have three examples. One of them is privilege escalation to sysadmin, how from a regular user I can escalate my privileges to sysadmin. And this is not normally possible under normal conditions, and I will explain when this is possible. The other example is, what if I am able to access the physical logs or physical table spaces? I mean, I can unload them and read them on a different platform. I can just extract the data. So another hack, like normally I don't have access to these, but what if I can somehow do it? And the third one is a bit different. It's SQL injection, because I think it's often overlooked in the mainframe world. So I want to talk about it a bit. So let's start with one example. So let's start with this hill. That's what we do in development. We usually describe the use case or the scenario. So I have two personas. I have Emil and I have Joe. And maybe some of you recognize this character. It's called Krteček in Czech. It's a little mole, and he's a very good guy. He's very helpful. So Emil wants help from him because Emil has a test system and he wants a certain DB2 authority. But Joe is unfortunately on vacation, so we cannot help him. So what Emil understands some internals, so he does some bad business how to get the privileges he needs. So as you can see at the bottom of the screen, Emil just wanted to execute display group command. So, but it was rejected because he doesn't have, he's not authorized to run this. So what Emil can do under certain condition, which I will explain in a minute, is, and did I tell you that you need to know a bit of assembler? But really just a few lines, don't worry. So Emil can do this thing, because Emil knows how the things work under the hood. He can write this short piece of assembly. He can then compile a link into a library and then execute. What this code does, it basically changes the identity of the address space. So if you submit the job, it runs under the submitter's ID normally. But in this case, what happens, Emil changes the identity of the submitted job to Joe, so back to the sysadmin. So now the job runs under the sysadmin authorization ID. And at the very last step, Emil uses DSNTIAD, this DB2 utility or the sample program that is shipped with DB2. And if you take a look at the very last line, it says grant sysadmin to Emil. And if you just runs this, the job completes. And what happens is that suddenly it seems like the sysadmin, Joe, granted sysadmin to Emil. And that's it. Now Emil has high privileges and can do whatever he wants. Now, normally this is not possible. So what were the assumptions, or what I used here to do so? So Emil, in this case, used an IPF authorized library, and he had an update access to it, which means that this small program that he compiled and linked, normally it wouldn't work under normal conditions. It needs to be linked into an APF authorized library. So if you have non-secure APF authorized library, it's so simple. Anyone can really do this thing and make himself a sysadmin. So I know sysprocs and DBAs know that APF authorized need to be protected, but sometimes they don't understand why. So here we have an example. If you don't, this is a simple example how someone can really escalate his privileges. On the other hand, this is not the single and the only attack vector. So let's say all your APF authorized libraries are secured, and then you think, okay, now I'm good. Wait a minute, because later in the slides, I have some other examples. What can be the other attack vectors outside of the APF authorization? Some of you may ask, okay, but this works only with internal security. And I will be talking about internal versus external security in a minute as well. But even if I'm using external security, there are some goodies for hackers, and I will mention them in a minute. But even if this is external security side, Emil, if he has access to APF authorized library, can grant himself a security admin and then grant privileges as needed as well. So I have some examples later, or some more notes. What can maybe happen here also, or what can help a bit, is if you have multi-level security. But again, if that's the case and the assumptions work, then Emil can also impersonate into the right person and grant the privileges. I didn't mention one of the assumptions is that I need to know the security or sysadmin or security admin in this case to change the identity. But usually it's not a big secret, because people usually know who is the admin in the company. But don't tell anyone if you don't need so, right? So keep it secret as well. Not everyone needs to know who is your sysadmin and what is his user ID. So how to fix this in this particular scenario? So definitely protect your APF authorized libraries, but that's a must for anything basically. So that's basically a must for all your security. If there is a single unprotected APF authorized libraries, your system can be in danger. The other thing that helps here is auditing. So my simple use case was that the sysadmin is on vacation, but now he's granting sysadmin to someone. So if you run some audit and you would see something like that, it could look suspicious, right? How is that possible that he's on vacation and granting sysadmin? So at least this can help. It wouldn't be like an immediate alert or something, but maybe at least you can see it in those audits. Any questions to the first example? I hope at least you understand what can happen if you have these unprotected APF authorized libraries. Second example is very similar. It uses the same assumptions, but now it's different. Emil wants to access some data sets that are normally just under Db2's control, and normal users don't have access to them. But Emil wants to run some standalone utilities such as DSN1 print to extract the data from the physical data set. And as you can see the message at the bottom, Emil doesn't have access to this data set. So he was requesting to read the data, but was not allowed by the security product. So, but again, if Emil discovers an unprotected APF authorized library, he can write a simple code here, like just a few lines of code, which gives him certain privileges that allow him to read basically any data set. So with this snippet of code, Emil gains some superpower and can read any data set, including those Db2 data sets. So, and later in the slides, I will show you what's going on here, because this is just some magic, you might think, but there is some logic behind it, and I will explain it in a minute. Assumptions for this example is very similar to the prior one. Emil just needed update access to an APF authorized library. And then he compiled and linked this program to that library and can execute. And within the same step, he can then execute any other standalone DB2 utility, because this change, what happened in the prior slide, applies to the entire address space, which means that the follow-up steps or any steps in the same JCL can access these data sets. Now, some of you may ask, so, okay, so if all my APF authorized libraries are secure, am I good? And unfortunately, I need to say no. There are some other ways. And again, I will show you in a minute. Some of you may ask, what if I have pervasive encryption? What if my data are encrypted? That definitely help for a moment. But if Emil is smart enough, he can impersonate as another user who has access to the key label. Or perhaps he can even become a security admin and grant the key label access to himself. So, I mean, pervasive encryption is good, but if you are not secured, then it can be broken as well. So, apparent fix here is protect your APF authorized libraries, because if Emil just tries that program in a standard like load lib, which is not APF authorized, the program would fail because he cannot do this change. It would fail terribly. So,
Emil, there's a question in chat about the load library.
Yeah, let me see. So the question is, when you use high-level assembler to update the load library, will that write an SMF record? And so, as far as I know, there is definitely those SMF30 SMF records that shows you about all the jobs. Update APF authorized library. I don't know if there is a trace about that. I'm sorry, I don't know. But I would say in general, auditing, any kind of auditing would definitely help to see these changes. I know that some security products can also monitor these changes, monitor activities in APF authorized libraries. So there are definitely tools. I'm just not sure if there is just a SMF record from top of my head that just collect this information without any need of configuration or security product. So I'm sorry, I don't know. I would need to take a look. Okay, thank you for the question. Let's continue with example 3. And as I mentioned, those two examples are targeting the local attacks. But what if I have my application and it's available for remote access? Can something bad happen? Yes, an example is SQL injection. And you may know it. If your application just builds a dynamic SQL and you don't sanitize your inputs, someone can inject a piece of code that can do some other things than you expected or you envisioned. And maybe I will go to the next slide so that you can see example. Some of you may know this this XKCD comics that briefly explains what the SQL injection is. And basically, this section is based or inspired by a session by my friend and colleague who just made an IDAC session about SQL injection. And I have links at the end of my session, so we will see this. So if you are interested into more details about SQL injections for DB2 for ZOS, there was a session at IDAC. So now let's see some examples. So let's assume I have this COBOL code, because normally people think SQL injection just affects the new applications, but it's not right. It can affect even this COBOL. So let's assume I have this COBOL application that will list all the employees that start with the first name I enter. So I have a field which I give to the user, and user provides the first name, and then I construct this dynamic SQL select command and execute it. So if I do it, and if I provide my input as Emil, then you will see select first name, last name from employee where first name equals Emil. So it will show me all Emils in my company. But what if someone enters a string like that. So what if the input is Emil quote or quote quote equals quote? This weird string, which doesn't make any sense, but if you think about it, and if you inject that into this where clause, you will see the where clause in the form where first name equals Emil or blank equals blank, which in fact is always true, and it will show me everybody. So it's a big difference, right? And you don't want to show everybody maybe in your application. So, and example here is with COBOL, because I see some customers maybe are having those existing COBOL applications, and now they are exposing them to the REST APIs or some modern interfaces. So be careful and understand what the application is doing, and that you can open it really to these types of hacks. What's the fix in this example? I mean, it's simple. It was dynamic SQL. So if you used static SQL and with host variables, you would be safe, because so if I change my code like here and I just use the static SQL and my where clause is just where the first name equals the host variable array that is from the not array, sorry, host variable that is entered by the user of the application. Even if he uses that batch string as in the prior example, now it will be a bit different. So let's take a look at the line 2 here. So if someone enters Emil quote or quote quote equals quote, then it will be where first name and then the entire input is as a string entirely, which means most likely no one has first name like that. So this will show nobody, and that's a big difference between show nobody and show everybody. So that was the fix here, that I would write it in the static SQL. But even if you have dynamic SQL, you need to sanitize your inputs, and there are even tools that can help you to identify such problems. So you can scan your code using some tools, and there are tools even available for COBOL. And again, if you are interested into more details, grab that session about SQL injection I have in my links. So hopefully, so far so good. I hope that you now have understanding what can happen if you are not secure. Now let's speak briefly about Db2 security in a nutshell. And I mean, I really condensed that to 4 or 5 slides because I wanted to be short. So I wanted to describe Db2 security in one diagram, and then I realized there is one existing at IBM documentation site. So if you follow that link, you will see this diagram, which is really cool. It's not in the PDF because it's interactive. So you can move your mouse and it will show you different things and what is going on and what's happening. So if you want to learn more, definitely go there, and it will show you details for different users and so on. This is really great. So I want to talk about 3+ topics here. Two first highlighted is authentication versus authorization, because sometimes people confuse that. So authentication means the identification and verification. So it means that when I log on to a TSO, it's me saying, hi, I'm Emil, and the system just confirms that, okay, I need your password, whatever, to confirm that it is you. So that's the authentication. The other thing is authorization, and that means that while I'm connected to Db2, and I want to select from a table, Db2 will check whether I'm allowed to see the rows from that table. So that's authorization. Important thing, Db2 native, internal versus external security. So sometimes people think that, access to Db2 is basically controlled by Racket, but that's, or by other security product, but that's always the case unless you turn it off. So, but what matters here is also the authorization to Db2 resources, and that can be managed by internal or external security managers. So keep that in mind. So Db2 lives in this mainframe environment. It's really great hardware and software synergy. So there are some hardware and software facilities that that can help to make your system secure. And I have heard this at one of the sessions that mainframe is the most secureable platform, which I like. It doesn't say it's most secure, but it's most secureable, which means you can make it very secure. You just need to use all the facilities here. Some of them are hardware. I will talk about them in a minute as well. Some of them are software. So together they really make the system secure, but you need to use them properly. A bit more words about authentication authorization. Now for authentication, you have some more options than just user ID and password. We have MFA and some other means what you can use, how to identify the users. And more on that is also in that article I mentioned at the beginning, written by Gaia. So make sure you read that and learn more. But what's important on this slide, or what I want to highlight, is Db2 connection and sign-on exit. They are sometimes overlooked, but they really drive some important logic, or they have some important logic. Basically, they decide or they drive what will be the primary or secondary out ID when you connect to Db2 and you run your SQL. And when I talk to customers, they know, oh yeah, we have them in SDS and exit. They were compiled some time ago. Maybe we just use the default, but not everyone knows what's inside and what does it do, what the exits really do. And that's what I have just followed. It's important to understand that this exit can modify the primary auth ID and also can influence the secondary auth ID, which means that if someone provided you with an exit with some code that modifies the primary auth ID, suddenly the user who is connected can change the identity to a different auth ID. So make sure you understand your security exits and how they work. Many customers are using default, which is okay, but make sure you understand what's in your shop, what we are using. Also, the thing that helps with confusion or to confuse people is that these exits work in different environments. So connection exit can work in those. So I have the 3 groups here, basically. Connection exit applies to the first and the second group. Sign-on exit applies to the second and the third group. So it depends on the type of your workload applications you are using, which of these exits apply to your environment. So sometimes people also don't understand what applies when and what's in use. So hopefully this chart or this table will help you. Briefly about the security, internal versus external. So as I mentioned, this is mainly about the authorization. Do I have access to this table? Can I read these rows? Can I do updates? So if you are using the internal security to Db2 native, that's all under control of Db2. So all privileges and roles are tracked in Db2 catalog. So there is certain tables, those sys, auth tables that keep track of this authorization. So that's how this is managed. But you can also use external security since some version of Db2. And this is driven by this exit. And then all the authorization comes through or goes through the external security manager. So Db2 will do these rack root calls and will call ESM, whether the user is authorized to do these types of operations. The important thing here is also that these two can be combined. So, and that happens often in the cases where you are migrating from internal to external, and you still keep some of the definitions in the catalog, and then your ESM is not able to decide, and then it falls back to the internal security. So make sure you understand what is flow in your company, what is if you are using external, internal, or both, because that can really also mean that in some specific cases, someone can get some data he shouldn't be able to get. Here is just a summary, internal versus external. So basically, if you are using grants and revokes, you are using internal security. If you are using the ESM control statements such as permit, then you are using external. So that's in a nutshell, basically. Now back to my example one. If you recall, in that short snippet, the code was manipulating some system control block, and that was ASXB control block, and there was a certain field that was modified, and it replaced the current submitter ID with the sysadmin user ID. And why this field? And then if you take a look into DB2 documentation, and this is a snippet from the security guide or managing security DB2 guide, it tells you that the initial primary authorization ID comes from this control block, basically. So if you know how to navigate to this control block and you have privileges to modify it, then you can influence who will be the primary authorization ID, basically. And that's what happened in example one. Because the code was running APF authorized, it was able to modify this system control block. Normally, it's not possible. Normal applications cannot do that. But in the case of IPF authorization, it can do it. And it modified this value and changed the identity. And basically, the job was running as if it was submitted by the sysadmin. So this is important. And that's also why I highlighted those exits, because the exits can drive this logic as well. So when you do this connect, or if you connect, DB2 runs this exit and passes as the default user ID this value. And now it depends on the exit what's going on. I have this. I call this slide "Goodies for Hackers" because there are some nice things. So if you can read the documentation and if you understand the control blocks, you can find the ways what you need to change to be able to do what you want. Also, one interesting thing is that installation sysadmin is bypassed by security exit if you are using Rakev. So which means if someone can impersonate as installation sysadmin, this is very dangerous because he can then manage security-related objects. Separate security doesn't apply to installation sysadmin. This is really high-profile user ID. It needs to be very protected. The one exception is that the multi-level security applies even for installation sysadmin. So if you are using multi-level security, this is good. This can help you. If not, make sure that your installation sysadmin is very secure. Last slide about DB2 security, and this is just for your reference. I just list the ZPARs that apply to security. So there are some highlighted ones. Make sure you understand them, and I will talk about ZPARs later in my last section about prevention or what you should do to secure your DB2. So, and this concludes my first half of my session. How am I on time? I think we have plenty of time still. So
we do. We have plenty.
Yeah, thank you. So if there are no questions, I will continue with more general topics. And as I mentioned, this is what I have learned from mainframe hackers, and I apply the knowledge to DB2. So I want to show you also those general terms and techniques so that you understand what's behind. So some of you may know, some of you don't, but there is really a small mainframe hacker community. And I mean, I'm talking about the good guys, about those ethical hackers that show what can happen, that can help you. I don't know how big can be the other side, those other hackers. I have no idea. But these are the guys that really did a great job, and they shared their knowledge, they presented, they have articles, presentations. I have some links here on the left hand. I have some links to their presentations. I highlight Philip Young, Chad Reconstrut. They are really great. I have seen their sessions. I have seen them even live, which is even better. There is one great site called also Mainframe Hacking, which contains the links to the sessions, to some other materials, and so on. So if you are interested, make sure you follow that link. On the right hand, I have a list of mainframe hackers I follow on X. It used to be Twitter. So I don't go there too often that much any longer, but I used to follow them. So those are really famous names in the mainframe hacking community. Phil Young was also in Orlando at Share, the last Share in Orlando. So he was presenting some great sessions about hacking mainframes as well. So really, if you have a chance, make sure you see their sessions. Phil Young and Chatri Kansut, they were also running what they called Evil Mainframe. It no longer exists because it was acquired by Broadcom, and now it is part, or it's becoming part of Broadcom education. But this was really a great penetration testing class, and I was privileged to be able to be there. And that's where I learned a lot really about the hacking techniques and the penetration test and so on. And that's how I applied the knowledge. So basically kudos goes to these guys. I just use the knowledge I learned and use that in Db2 context. So as I said, those are those ethical hackers. So they already helped to fix some problems. They reported problems to IBM. So IBM published some fixes. So this is really all good. They are advocating for good practices for pen testing and all these things. They also identified those different attack vectors. So they were showing different techniques how a mainframe can be hacked. And I will show you some of them and some techniques. And they also created a lot of tools. And because they like open source, many of these things are really publicly available on a GitHub, and I think mainly on GitHub. So let's take a look at the first one. So what hackers can use. So let's say you have someone who is already in your company and he wants to get into your mainframe. So he needs to somehow steal user ID and password, most likely. So some people have those stickers. So then stealing a password is simple, but some don't. So what they, for example, have, or what they show what's possible, is they have this man in the middle 3270 proxy, which is just basically a honeypot, where you can, it looks like a regular screen where you provide your logon information. So I sometimes see it even in my office. Someone leaves his laptop and just doesn't lock it. Well, that's great, right? Someone can install this and steal the password. So this is all possible. So make sure you secure your password. Don't tell anyone. Make them secure. Keep your laptop always locked if you are not at your desk, and so on. Some really basic practices. In the past, they were also running this public mainframe logon screens project. I think it's no longer working, but basically they were really scanning the internet and capturing those ZOSs or mainframes that were accessible from public. So I have some examples. So you can go there and see some examples. As I mentioned, I think it's no longer working, but at least you can see. Hopefully you are not there listed, or if you were there before, hopefully you are not there these days. The other thing that's important or very cool are enumeration tools that can help you to understand what are the services running on your system and whether they are exploitable or opened or not. And I draw these two circles around the mainframe. So because there are tools that can help hackers to see what is really running even from the outside. So what servers are running in your company, what ports are open, and so on. Then if someone is able to get into your company, he can start enumerations on the internet and can see, okay, what are the Kix transactions running on that server? Is it a mainframe or not? What are Apple IDs, and so on. And once someone is able to get into the mainframe, then there are some other enumeration tools that can see what are the subsystems, what are the TSO users, what are the APF authorized libraries, and so on. So I will go through some of them quickly. Nmap. It's one of the famous tools, and I mean it was available for distributed platforms for years, and now there is also a support for ZOS, and it can do really cool things. It can detect whether the server is really a mainframe or not. So you see example in the middle of the screen. So I just ran this nmap, and then you can see it's saying, oh, it's IBM Telnet 3270. So you are sure this is a mainframe, and you can even see the version of ZOS. It's 2.5 in this case, right? But it was enhanced, and it can really do enumerations of different services. So I have examples: 3270 screens, Apple ID, gigs transactions IDs, and TSO users enumerations, and so on. So under normal conditions, some of them shouldn't work, but some of them will work. So make sure, if you want to assess your system, maybe try some of them and make sure that that you are secure here. At the very bottom, I have a note about clear text, and I know that some customers are still using clear text protocols such as Telnet, FTP, and there are tools that can really monitor this network traffic, and if there is some clear user IDs and password, that's really bad, right? And I know in some shops it's still being used because they implemented FTP years ago, back then when the security was not that big topic, and now it is really not secure. So make sure you use secure protocols. I like these enumeration tools that really work on the mainframe itself. So once you have access to the mainframe, there is a great script I will show you in a minute that can show you really cool information. Even if you are not authorized, it's just a rex script that can provide you with this information. And the beauty of this script is that it doesn't require any authorization, and it reads all the information from non-fetch protected control blocks. So example is a security database. So if you have your security product, it will most likely not tell you the dataset name of where is your security database. So if you type the command, it will tell you command not granted. I will not show you. But the information is still in a control block somewhere, and this rex script can go there and extract the information. It can show it to you. So the script is called enum. Very simple. And again, this is a link to GitHub, and you can use it for enumerating all these things. I highlight two things. It will show you all APF authorized libraries. And as I mentioned, this is critical. If someone figures out a single unprotected APF authorized libraries, your system is in a danger that the hacker can do almost whatever he wants, basically. The other thing is SVCs. So, and some shops have custom SVCs that can grant privileges. Some vendors maybe have some SVCs that can grant privileges. So there are some tools that can discover these types of SVCs, and they can grant you or provide you access even without being APF authorized or running from the APF authorized library. So if there is this, sometimes they call them magic SVCs, and they can grant you these privileges. So if someone figures that out that there is a magic SVC that can do this thing, he can then do the thing that I did in example 1 or 2, even without an update access to an APF authorized library. So again, this is another attack vector that can be exploited. So the other tools they have, and there are many, are shells. Hackers usually use the Linux shell or some Unix shells in general, and they have some tools how to provide it even with for the mainframe. I especially like the T-Shocker, which is in the middle, and that's basically a piece of JCL and rex. So you just submit this JCL if you can submit via FTP, and it executes a rex script that basically creates a command interpreter, and then from your workstation you can connect to it, and you have your shell. So you don't need SSH, you don't need Telnet, you just need, if you are able to submit a job, you can do it. And you need to be able to open a port, by the way. But if you don't have a secured environment, you can do it. And then you have this listener which listens to the remote connections, and then you can just type the Unix commands. Yeah, password cracking is possible as well. So there is this John the Ripper tool, which is the tool that is available for other platforms for years, and now it has support for ZOS as well. So it uh, can can crack the passwords in a racket. But I think it's no longer that true because IBM changed the algorithm how they save the passwords in the database. So if you kind of reorg your security database, this shouldn't work, but it depends on what you have. So, but be aware that there is a tool that can crack the passwords. Metasploit is an automation tool, and that's again it's used by pen testers for testing or pen testing distributed platforms applications, but there is a support for ZOS as well. And there are a couple of scripts that can be executed. And usually this framework is used to test known exploits, known vulnerabilities, and so on. So example at the bottom is APF privilege escalation JCL that works if there is unsecured APF authorized library, uses FTP to upload the job. And this job, when submitted, modify some control blocks to grant a special privilege and super user in the USS to the user who submitted, and then he can do almost anything he wants. So if you are interested, make sure you review this or you take a look at this Metasploit script APF privilege escalation JCL. It's really cool. I think I'm talking too slow. Any questions so far? I don't see anything. So let me go on. So what can be those common attack vectors to break into your machine? So I mentioned many times, APF authorization. So this is what I call this slowest hanging fruit. So if someone discovers a single unprotected APF authorized library, the system is in trouble. There are some open source tools again from these hackers. You can check them. They can help you to see if you have any. You can run security products report, right? They can show you what are your APF authorized libraries and so on. So there are tools that can help you with that. I'm just providing some open source ones. The second thing I already mentioned is magic SVCs. So they can provide or they can authorize users, and if they do it without proper checking, then that's dangerous. Again, there is a tool that can scan for some known magic SVCs, and if it discovers one, again, your system might be in trouble because then the user can do the bad things even without requiring APF authorized library. The third example I have here is, okay, so I cannot do anything. I cannot update any APF authorized library. There is no magic SVC. But what if I can submit the job as another user who has the privileges? So, and there is this surrogate class. So if I have a read access to this security resource user ID.submit, then I can submit a job as the user ID. I just in my JCL I just need to change the user. And this is nice one because if you discover that you can submit job as another users who are more privileged, then it can even chain to submit a job as another user and so on. And I think there is already also some tool that can create this tree of user ID chains of these surrogate classes. External security products, I will talk about them in a minute also, because that can be an attack vector as well, especially if it's not properly configured and if there are many high privileged users and so on. Other examples, TSO, of course, that's a nice one. If it's unprotected and anyone can log on, can use Rex and Unix and so on. So that can be used. USS, sometimes overlooked. One thing I want to mention about USS is APF. APF authorization is available for USS as well. It just works a bit differently. And because USS is sometimes overlooked, you may figure out that you are able to APF authorized USS program. I just tried on a test system. I just wanted to give this extended attribute. APF authorized my program, and I was able to do so. So now my program was APF authorized. And I can do the same or very similar techniques I used in example 1 or 2. And I have some more. I don't want to go into details. FTP, again, like used heavily. Kicks, many applications are Kicks based. There is a hacking tool called Kickspawn, which can help you to pen test your Kicks server if there are any issues with that. NJE, I never used network job entry, but basically that's a way how a mainframe can submit a job to another mainframe. But there are some techniques how a workstation can pretend that it's a mainframe. I think this was fixed already. I mean, it's not working that simple as was in the past, but make sure you have your NJE secured if you are using that. External security manager. So when I talk about Rakev specifically here, that's what I have on the charts. So I mean, they are great, but they need to be also configured properly. Sometimes people start implementing the security and they do it in the warning mode, which means that there is just a message that access is denied, but the access is granted anyway. And it's just there is some period of time where this warning mode should be applied, but maybe sometime just forgot to turn this into the fail mode. So it's warning mode forever, which is a problem. Also, if you understand how Rakev works or what the decision logic, you can do some things as well if you have the privileges, like as I did in example 2. And that's what I have on the right hand. If you take a look at the right hand and you see the red box, and that's basically what I used in example 2, because I was able to write a program that was in an APF authorized library and was APF authorized, and it granted this operations attribute, which means that the address space then was able to read the Db2 datasets. So if you understand this logic and how it works, and you figure out, oh, this is this operations attribute, and if you are able to change it, because normally, of course, you are not able to modify this, but if you figured out that you are able to do it via APF or SVCs or some other means, then you can change it and you can read the data sets. So, and this is where I go to this famous ACE control block. Some of you may know it. That's basically the runtime picture of your profile, or so that's what the external security manager creates when you verify yourself or when you authenticate. And it contains information about you and the attributes. And some of the attributes, I highlight them in the slide. And one of them is, for example, is operations. And if you read that, if you follow the link, it shows you that it can access, if you have this operations attribute, you can access any data set regardless of data set rule. And that's what was used in example 2, for example. So if you understand this security context, this user profile and this control block, and again, you are able to modify it, you can do very bad things. Fortunately, in ZOS 2.5, I believe, IBM introduced this functionality called AC modification detection. So now you can turn this on and monitor if there are some programs that do it. On the other hand, there are some legitimate uses or usages of this AC control block. And sometimes this is really not a problem. But then you need to work with IBM, with your vendors. So don't think that if you turn this on and prevent all modifications from happening, it can really cause headaches and troubles, because some of the products might not even work. So I think it's good to be aware of it. Maybe turn this on with some exceptions and understand what it does, because there are some documented use cases or when this is really legitimate use. Here, I mentioned in one of the slides the hardware and software synergy, and this is more about the hardware. How does it work? So there are those storage keys and PSW keys. So each application has a key. Normally, application are with a key 8, and the pages in the storage also have a key. And if there is no match, then it depends. Maybe you have at least read-only access, but maybe you don't even have the read-only access. DB2 normally runs with key 7. So under normal conditions, applications cannot modify any DB2 data. And also some of them are fetch protected, which means that applications, if the key doesn't match, they cannot read that. And that's the case of the buffer pools, for example. So you cannot read them normally. But again, if you can authorize the application somehow, and it can change the key, then it can read any data sets, any data in the storage, and it can even modify the data. And that's why I highlight APF again. I think it's for the 10 times in my slide, because this is really what can happen if you allow someone to modify or to create a load module in APF authorized library. Then it can change its supervisor. Sorry, I'm sorry, I'm hearing some background noise. Or was that a question? I don't see any question. Okay. So if anyone can do this and change the key, then the application can access basically any data that are in storage. And last one about APF authorized. This is basically what the hackers call game over. If you have update or higher access to APF authorized library, it's a game over. You can do whatever you want. And this is just a repetition of what I've said already. So now I'm going to the last section, or this is the last section of my slides. And I think we should now talk about, okay, so we have seen what can happen, now how to prevent these things from happening. So what you should do next. First, don't panic. I'm pretty sure you are okay and you are good. Second, I would say educate yourself and your teams and implement security practices. So I just list some examples here. Make sure that you are doing some security scans. You use all the techniques you can, pervasive encryption, MFAs, whatever you have, audits, monitors, and so on. On the right hand, maybe you should do some pen testing, and maybe you already have some pen testers in your company, but they are just working on pen testing distributed applications. Maybe you just need to educate them to also do the mainframe pen testing. And that's possible. I mentioned some of the tools. They are open source. Most likely, if you have pen testers in your organization, they know Metasploit, and now it's available even for ZOS, and they can test ZOS with Metasploit as well. So maybe that's also something that can help you to make your system secure. If nothing else, then take a look at this link I have at the on top on this slide. So Center for Internet Security is publishing these benchmarks where they provide some recommendations, and they ran this report, or they created this report for DB213 as well. Most of it applies to DB212 as well. So make sure you take a look and download. I think you just need to register and you can download and read this document and follow the recommendations there, because if you do so, your system will be very secure then. And I have just some highlights. So one of them I highlighted is that protect your system data sets, right? And those are those system data sets that normal users shouldn't have access to, SDSN load, SDSN exit. Protect the subsystem access, right? Just make sure that only the user IDs that should work with DB2 are allowed, and the rest is not permitted to DB2. Make sure you apply the security practices for ZPARs. And by the way, some of the recommendations are different from the recommendations that are in the documentation, DB2 documentation. I have one example here, this extended security field. So the CIS benchmark recommends this extended security field to set to no, while the DB2 documentation specifies a value of yes, but there is a reason, because if you have yes, it helps you for debugging and make sure that you have proper error information if something fails. If you have no, the information is very limited. So I mean, these go like against each other. Sometimes you want more details, sometimes you don't. But from the security perspective, you don't want the details, because those details can help the hackers to identify what's the system, and some more information that can help them to use some attack vector. So I mean, sometimes it's challenging and difficult. So I understand why the documentation recommends yes, but from the security perspective, no is better. And that's basically what I had. Oh yeah, and I asked ChatGPT again, so you can do as well. What I wanted to show you are some links and references. So I think I have some collection of good IDAC presentations. If you are attending IDAC, make sure, if you see the names, make sure you attend and see the security sessions if there are any. And of course, the IBM documentation is a great source of all the information. And with that, that's all from my side. I just want to thank you for your time. Hopefully, you are still with me. Hopefully, you enjoyed and you learned something. This is a picture of our twins. I just took this picture and then it reminded me. So they are on top. At the bottom, I think you recognize the guys at the bottom. So, but it looked very similar to me. So I just wanted to say thank you. Greetings from our next gen hackers. And if there are any questions, comments, yeah.
Are there any questions? You can drop them in chat or come off mute.
Yeah. Or if you have questions later, feel free to send me an email. My email address is on the first slide, and I guess the slides will be available as well as the recording, right? So
Yes.
Feel free to reach out later if you have any questions. If not, thank you for listening. I hope you learned something, and hopefully you also have some links to follow and learn more.
Thank you.
Thank you. I see something in the chat.
Yeah, there's a couple of Stephen has raised his hand. If you want to come off mute, Stephen, that's fine. See your hand raised. Or you can drop a question into chat. Maybe you were waving and it wasn't a hand raise.
So I see some thank you messages in the chat. So thank you for your thank yous.
So I've got a couple of announcements I will make while people are coming off mute to ask questions. Hopefully you can see my screen again. Just some really quick announcements. There's a couple of articles and news. So as I mentioned, IntelliMagic is now an IBM company, and they have just released an article pretty recently about, or I'm sorry, they've just released their IntelliMagic vision for ZOS. If you want to read up about it, it's the first release since the acquisition. You can check that out, and they're a sponsor of our group. There's a couple of jobs needing DB2 skills available on the Planet Mainframe job board. So that's at jobs.planetmainframe.com. I encourage you to get involved and find us on social media, LinkedIn, Twitter, or X, and Facebook. And as was mentioned, all of our sessions are recorded. You can capture those recordings on YouTube, but also virtualusergroups.com. And if you are not yet signed up, please sign up for our newsletter so that way you'll get the announcement of our next meeting, which save the date for July 16th. So we'll make that announcement and release our newsletter and let you know when the recording, transcript, and presentation are all ready from today's session. Did we have any last questions before we go? I can't pull up my chat for some reason. Oh, great.
I don't see any question in chat.
Okay. Well, I think we're great. Emil, thank you so much for the presentation. Very, very interesting stuff. And thank you for all of the resources that you provided to go along with it.
Yeah, thank you for inviting me. And I hope all the links work. If not, let me know.
Will do. Will do. Thank you so much. Have a good day, everyone.
Thank you. Bye.
Bye-bye.